Hey, what's up, guys? I'm just getting everything set up here. Oops. Oh no, I might have to log back in. Bear with me. I'm not sure if this will time me out or not. Let me check. Let me go back to YouTube. I might have to go to one of those. Let me try this. Did I misspell it? Let's see. Let's search for that. Make sure the stream is up and running. Anyhow, good morning. Happy Saturday. Right now, I started taking the Linux class, the introductory class, the free one, on linuxfoundation.org. I went ahead and created one of the free accounts. And I highly suggest that you do it too, if you're new to Linux, as I am. So I went ahead and created a free account on the linuxfoundation.org. And a lot of the classes that they offer are actually free on there. So I went ahead and signed up for the first free class. And the name of it is... Where did I put it? Introduction to Linux, and then there's like a course number. I think it's like LFS101. I believe that's what it's called. So I've been taking some notes on it. I just want to make sure that the stream is up and running. I'm not sure. I don't want to be sitting here talking to myself. So let's see here. I'm just going to put in here because I'm kind of curious. Type in chat the distro of Linux you are using, please, because I'm kind of curious to see what other folks are using. Therefore, I can kind of, the videos that I make in the future on the new YouTube channel that isn't up yet, I hope to have it up tonight and running. I've already requested from YouTube to be able to live stream on that channel. The name of the channel is just Tux Distros, which is the same as my wallpaper background right there. And that's going to be my little logo because I don't want to get... I've been streaming Linux stuff on my WeatherZone411 channel for the last couple of days. And it's kind of... It's not a bad thing. It's just that I have a Discord that I run for that channel. And I had to create other... chats in there for Linux, and sometimes people accidentally put weather stuff and the Linux stuff and the Linux stuff and the weather stuff. So to avoid that, I went ahead and created another YouTube channel just for the Linux stuff. So I'll probably be streaming on that one tomorrow. If you type into YouTube, if you search Tux Distro, it should come up with like a little icon of a penguin. And it's like, I think it's like orange and black or red and black. So anyhow, actually, let me see if I can pull it up. Let's go to YouTube really quick. I promise I'm going to get into this, but real quick, I just want to see if I can bring it up. Let's go to YouTube and type in, let's put in Tux distro. And there it is. So it's like a yellowish black or orange and black right there. And then when you go to the channel, I don't know why it's showing the orange and black when I made it black and white, but anyhow, I've got one little video up on there that's only like 50 seconds long. It's like an intro to what the channel is going to be about. So if you wouldn't mind, go ahead and subscribe to that channel too, because that's after tonight. There was like a little timer on YouTube that said you had to wait 24 hours before you could start streaming on that channel. So I think I did it last night around 6 o'clock. So after 6 o'clock, I can start streaming on that channel. And that's where I'm going to be uploading all my Linux videos too. So go ahead and subscribe to that one, turn on notifications so you get notified when I do upload a new video to it. But I want to go ahead and get into this. I started this last night. Hold on, my dog just came in here. I know if I don't shut the door, he's going to jump up here on my lap. So it's really dark in here. Let me turn on the light. There we go. Now you can see a little better. So in case you're wondering what in the world that is up there, that's for my weather channel. I have the radar going right now. I'm watching the storms over Virginia, Maryland, Delaware. There's some storms going up in the New England area too, up in the Halifax, Nova Scotia area. So I've been keeping an eye on those. So anyhow, let's get into this. Let me, I'll just recap some of these notes that I took. I've only gone through like the first 3 or 4 pages of the introductory course. I have a feeling that I'm going to be using the terminal a little bit during this. So I'm going to leave that right there. And let me pull up my notes of what I've taken so far and go over those really quick. So far what I've covered in this course in just the first like 10 minutes. The name of the course is Introduction to Linux LFS101. So basically what they've covered so far is just like 3 main distribution families of distributions, I guess. They went ahead and described a little bit about Red Hat Family System, or RHEL. So if you hear me say RHEL, that's what it stands for, is Red Hat Family, or I'm sorry, Red Hat Enterprise Linux, which heads the family that includes CentOS, CentOS Stream, Fedora, and Oracle. I don't think CentOS is supported anymore. If I'm not mistaken, I think they stopped support for that or stopped updating that back in 2021. But I think CentOS Stream is still supported. I think that's the one that's still going. And of course, Fedora is still going. So they go on to explain a little bit what Fedora is, giving us a little bit of background. It says here that Fedora serves as an upstream testing platform for RHEL. CentOS is a close clone of RHEL. In fact, CentOS has been part of the Red Hat since 2014. It supports multiple hardware platforms. It uses DNF. What else do they have here? RHEL is widely used by enterprise that host their own systems. Then it gets into SUSE. I know people pronounce that different. You know, some people pronounce it SUSE or Susie. I don't know. I've heard it pronounced a whole bunch of different ways. Anyhow, the relationship between SUSE Linux Enterprise Server, or SLES, is OpenSUSE, which is the free version. I think anybody can download that for free. Actually, I think that was the very first version of Linux that I was exposed to when I was living out in Oregon. A classmate of mine was using it on his computer. And I was running, of course, Windows at the time. That's all I really had access to. That's all we used at school. So that's what I used. But he was running a version of SUSE. It was probably like one of the first available for free. and I was like, what the heck is that? It looked really cool. And he ended up giving me a copy of his, and I went ahead and back in those days, I can't remember what I was using for dual boot. It was probably VMware, something like that. Anyhow, then they go into talk about a little bit about the Debian or Debian family system, which includes Ubuntu and Linux Mint. The Debian distribution is upstream for several other distributions, including Ubuntu. In turn, Ubuntu is upstream for Linux Mint and several other distributions. Is commonly used on both servers and desktop computers. Debian is a pure open source community project not owned by any corporation and has a strong focus on stability. Debian provides by far the largest and most complete software repository. Some of this is not interesting. Let's see if it gets into a little bit more of Ubuntu. It doesn't really. It does say Ubuntu has been widely used for cloud deployments. While Ubuntu is built on top of Debian, it is GNOME based under the hood. It differs visually from the interface on standard Debian or Debian, as well as other distributions. So anyhow, these are they kind of like provide a couple little pictures here of the three different distributions. The one in the top left is a VM. They're showing it under a VMware. The first one I think is Ubuntu on the top left. The one on the top right, I believe, is CentOS, if I'm not mistaken. And then the one in the bottom center is SUSE or OpenSUSE. I might have to download OpenSUSE and put that in a VMware and just run it for the heck of it, just to see what it looks like nowadays. The one that I used was from like 20 years ago. It was like a really old distribution. So anyhow, I don't know what page I'm on if you're following along on the Introduction to Linux LFS101, but I'm only like 4 or 5 pages in. So I'm going to go to the next page. And then it says, focus on 3 major Linux distribution families. In the next chapter, you'll explore the key components that make up Linux distributions. For now, it is important to understand that this course is focused on 3 major Linux distribution families in use today. These families are not static. Linux continues to evolve as developers and contributors identify new needs and create solutions to address them. In some cases, this innovation leads to the creation of an entirely new distribution. In others, it results in extensions and variations built on top of the existing distributions, further expanding the families that already exist. For a rather long list of available distributions, see major distributions from DistroWatch. And then here's a little... Actually, I'm going to take a screenshot of that, because I'm going to use that for my website later. There we go. And the distribution that I'm running right now, in case you're wondering, is just Linux Mint. It's the one that I downloaded that I thought was the most user-friendly for me, the easiest to learn. Actually, I just installed it on my son's laptop. He's going to be getting into it here soon. Hey, Siri, what's going on? And you're going to make my phone go off. I forgot to call you, dude. What's going on, buddy? I'm just going over. I took your advice and went ahead and signed up for the class on the Linux Foundation. And I'm just a couple pages into the first chapter. So I'm just taking some screenshots and taking some notes over here in Notepad. It's pretty good so far. I haven't really learned anything new. One thing that I did learn new so far is that I didn't know that SUSE was like one of the big 3. I guess the big 3 major, oh gosh, I can't think of the right terminology to use. Top 3 in the chart. There's Debian, Red Hat, Enterprise, and then SUSE, and then other distributions, and then it kind of breaks it down, as you can see in that little chart right there. So like I was saying, when I first started, the new YouTube channel that I'm going to be using for these kind of videos is that right there, that Tux distro. So if you type that into YouTube, you can go ahead and subscribe to that channel, because I'm going to create a new, what's it called again? I forget what it's called. What's that one program that we use for chatting and stuff like that? I can't even remember the name of it right now. Hold on, let's see. Where is that? Oh, Discord. I'm going to create a totally new Discord for that. Just so things don't get mixed up for the weather guys, because things can get, like, sometimes when we post pictures and stuff, it'll get all mixed up. So anyhow, long story short, I'm creating a new Discord entirely for that new YouTube channel. Oh my gosh, you got to stay up until 5 a.m. your time for Formula One Las Vegas race. So that's the perfect time. That's awesome, dude. What time is it over there now? It should be, according to my clock, it's 7 p.m. there. That could be wrong, because it's noon here Central Time in the United States, 6 p.m. UTC, which should make it about 13 minutes after 7 Berlin. So anyhow, I'm going to continue to go through these things. This is probably going to be like really basic for you because you're much more advanced. But if you want to add something in chat, please do, because a lot of us are just learning this stuff. So it's really good that we have some folks that are really experienced and have a lot more knowledge than us noobs. So please feel free to chime in and let us know. I'm going to click on this link really quick. I think I already have it saved to my favorites, but I'm just going to click on it for the heck of it. So this is the webpage that I've been reading a lot lately, the distrowatch.com. It says, put the fun back into computing, use Linux BDS. So I've just been, over the last week or so, every day or whatever, I go on this website and click on these different links and check out the different distributions that are available. Some of them are really cool. Some of them are very specific, though. Some of them are for folks that like to code and stuff. I don't know why they would need to use a totally different distro for that. Maybe for testing purposes, I'm guessing. But they go over most of the major ones, pretty much every distro, but they have different articles here. Here's Ubuntu, here's Mint, here's Arch. And by the way, I did go ahead and install Arch. I got it to work. It wasn't that hard. I just followed the instructions step by step on the Arch documentation, the installation guide, and it worked pretty flawlessly. I didn't like the user interface at first, but I went ahead and downloaded, it's not called Mint, it was called something else. I can't remember what it was called, but I downloaded it and it was okay. Again, I think I'm just going to end up staying with Mint. I'm still going to experiment in VMware, trying out different distributions for different stuff. But I don't think Arch right now is my cup of tea, but it was very good as far as speed goes. Everything was very snappy. Even on my old computer that I'm using here, it was super fast. That was really impressive. So if somebody has a really old machine or something like that, I haven't had an issue with any distribution being like slow or anything, but Arch was really, really snappy. I'll give it to them for that. But some of these distros, I can't even pronounce the way they are. But anyhow, let me get back into the intro, because I've been like itching. Last night I wanted to do it, but it started getting really late and I didn't get to finish it. The next page is going a little bit more over, it looks like Red Hat family. Red Hat Enterprise Linux heads the family that includes CentOS, CentOS Stream, Fedora, and Oracle Linux. Fedora has a close relationship with Red Hat Enterprise Linux and contains significantly more software than Red Hat's enterprise version. One reason for this is that a diverse community is involved in building Fedora, with many contributors who do not work for Red Hat. Furthermore, it is used as a testing platform for RHEL. We will use CentOS Stream and CentOS more often for activities, demonstrations, and labs because there is no cost to the end user and there is a long release cycle than for Fedora, which releases a new version every 6 months. So I guess I'm going to have to download CentOS Stream and put that into the VMware for some of these exercises that they're going to be doing. So I'll download those tonight and put them in the VMware, and hopefully they run good. And then we can try out some of the exercises that they give us. The basic version of CentOS is also virtually identical to RHEL, the most popular Linux distribution in enterprise environments. However, CentOS 8 has no scheduled updates after 2021. So this course may have been written probably about 4 years ago. The replacement to CentOS 8 Stream is CentOS 8 Stream. And that's probably a lot higher now because this article's kind of old. The key difference between the two versions is CentOS Stream receives updates before RHEL, whereas CentOS receives them after. For most purposes, this matters very little, and not for this course. While there are alternatives to CentOS Stream that resemble the older CentOS, for this course, CentOS 8 Stream works just fine. And then here's another graphic up here showing the hierarchy of Red Hat Enterprise Linux, and then it branches off into CentOS on the left-hand side and Fedora on the right-hand side. So let's go to the next page. Let's see. Key facts about the Red Hat family. Some of the key facts about the Red Hat family distribution family are: Fedora serves as an upstream testing platform for RHEL. CentOS is a close clone of RHEL. In fact, CentOS has been part of Red Hat since 2014. It supports multiple hardware platforms. It uses DNF, the RPM-based package manager, covered in detail later in this course. How to install, update, and remove packages in the system. RHEL is widely used by enterprises that host their own systems. I'm going to continue to the next page. And then we get into SUSE. The relationship between SUSE and SUSE Linux Enterprise Server, or SLES, and OpenSUSE is similar to one described between RHEL, CentOS, and Fedora. We use OpenSUSE as the reference distribution for the SUSE family, as it is available to the end user at no cost. Because the two products are extremely similar, the material that covers OpenSUSE can typically be applied to SLES. So that's another one I'm going to have to download. I'm going to have to go in here tonight and download all these different distros and get them up and running in VM. What version am I using? Oh, actually, I'm using VirtualBox, I think. I think that's the one I'm using. So I'll get those all prepared tonight. So when we get farther into the course, we can just like start it up and run it. Key facts about SUSE family. Some of the key facts about SUSE family are listed below. SUSE Linux Enterprise Server is upstream for OpenSUSE. It uses RPM-based Zephyr package manager. We will cover that in detail later. To install, update, and remove packages in the system, it includes the YAST, yet another setup tool application for system administration purposes. SLES is widely used in retail and many other sectors. The Debian family, or Debian family. The Debian family distribution is upstream for several other distributions, including Ubuntu, which is now one of my favorites. I downloaded that one the other night and ran it, and I had a really good time using it. It wasn't just like Mint, but it did have a Cinnamon version. So if you like Linux Mint Cinnamon and you want to use Ubuntu, there is Ubuntu Cinnamon version that you can download, and I really liked it. I put that in the VM machine. And I also used it on that website where you can just go in and test out all the different distros, which is super awesome. I bookmarked that. Let me see what the name of that one is. Oh, where's that? Oh, I can't find it now. Maybe I didn't save it. I know I saved it somewhere. I just don't know where it is in my favorite list here. But it's super cool. I'm going to be using that on the next stream too. It's pretty awesome. I must have used like 10 different distros the other night on that website, and it was super cool. Debian provides by far the largest and most complete software to its users for any Linux distribution. Ubuntu aims at providing a good compromise between long-term stability and ease of use. Since Ubuntu gets the most of its packages from Debian's stable branch, it also has access to very large software repositories. For this reason, we will use Ubuntu LTS, which stands for long-term support, as the reference for Debian family distributions for this course, which I'm glad because I want to learn more about that. Next page, key facts about the Debian family. Some key facts are the Debian family is upstream for Ubuntu, and Ubuntu is upstream for Linux Mint, which is the version that I'm running right now. It uses DPK-based apt package manager using apt, apt-get, apt-cache, etc., which we will cover in later detail later. To install, update, and remove packages in the system, that's what I'm most familiar with, is the apt. Now, when I was running Arch the other night in the VMware, they used something totally different, and I think it was called Pacman. So that was kind of weird. I was reading some of the documentation that came with the help manual in Arch, and I was like, what's this Pacman thing? And then it finally clicked that Pacman is what apt is to Debian, or to Ubuntu, or Linux Mint. So that was a little weird. But I thought that all Linux systems would use the same thing, but apparently not. While Ubuntu is built on top of the Debian and is GNOME-based under the hood, it differs visually from the interfaces on standard Debian, as well as other distributions. Let's see what's next. More about the software environment. The material produced by the Linux Foundation is distribution flexible. This means that technical explanations, labs, and procedures should work on almost all modern distributions. That's good news, because I was worried about that. I thought I was going to have to use VMware when I'm streaming, but maybe not. Maybe I can do everything through Linux Mint. I'm hoping that's what we're going to do, because I think the VirtualBox might slow down the stream because it uses a lot of system resources and my computer isn't that strong. So we'll see. Keep our fingers crossed. While choosing between available Linux systems, you will notice that the technical differences are mainly about package management systems, software versions, and file locations. Once you get a grasp of those differences, it becomes relatively painless to switch from one Linux distribution to another. The desktop environment used for this course is GNOME. As we will note in the graphical user interface chapter, there are different environments, but we select GNOME as it is the most widely used. All right. Congratulations on completing Chapter 2, the Linux Foundation. Take a quiz to check your understanding of concepts of what you've learned so far. What are some of the I'm going to let you guys answer these if you want. Hold on. Oh, wait a minute. Theory just typed something. Debian is short for Deborah and Ian. No way, I didn't know that. The husband and wife who created it. They have since split, and Ian was the only developer for a while. So Debian is pronounced like Deborah. So how would that? So what's the correct pronunciation? Deborah-ian. What are some of the objectives of the Linux Foundation? Select the answers. To promote Linux and provide neutral collaboration and education, to improve Linux and technical platforms, to support the work of Linus Torvalds, to manage Linux and Unix. I think that would probably be A. Next question. Debian, or hold on, let's try it. Debian, Debian, Deb, Ian. Oh, okay, now it kind of makes sense. Deborah and Ian. Deb, Ian. Debian, Debian. Okay, all right, that makes sense. Oops, I typed in the wrong password. I'm updating, I'm running updates on my son's laptop that I set up for him last night. I'm just putting Linux Mint on it. So if you guys see that in the background, that's what that is. I'm just installing some basic stuff for him, like some radio app, the graphical tool where you can like paint and stuff like that. So I'm downloading this for him. Debian provides the largest and most complete software repository to its user of any Linux distribution, true or false. The largest and most complete software, I'm not sure about that. Wouldn't it be the one above Debian, which is, well, no. Well, that might be true. Largest software repository, because that includes Debian would include, I believe, Ubuntu, Linux Mint, and like all those other ones. Now, I don't know about SUSE. SUSE, I'm only familiar with CentOS and Fedora being under SUSE, and then Red Hat had which ones? Fedora and the other one that they were talking about on there. So I'll go ahead and say true. What the heck? I'm not sure. We'll say true. Correct. Yes. Fedora serves as a downstream testing platform for Red Hat. Like, no, I think it's the other way around. I think it's Red Hat Enterprise Linux. Oh, wait a minute. Is the upstream, right? Fedora serves as the downstream testing platform. I'm going to go ahead and say true because I think Red Hat Linux Enterprise is on top and down from that is Fedora. So I'll go ahead and hit true. Incorrect. It's false. Oh, man. So I'm confused about downstream and upstream. I thought Fedora would be downstream. Oh, or do they mean, are they talking about CentOS being the testing platform? I'm not sure. Red Hat distribution family includes which of the following? Well, I know off the top of my head, CentOS and Fedora, right? Red Hat distribution includes which of the following? Well, definitely not Ubuntu because that's under Debian or Debian. CentOS, yes. SLES, I'm not sure. OpenSUSE is totally different, and Fedora is under OpenSUSE, I think. So I'm going to select CentOS. And did I get it right? It didn't tell me. I only got 1 of 4 correct. What the heck? I thought I got them all right, but 1. Review the questions. Let's see what the correct answers were. Okay, I got the first one right. And Debian provides the largest, most complete. True, I got that one right, I thought. Fedora serves as a downstream. Okay, I understand why I got that one wrong. Wait a minute, Fedora Red Hat distribution family includes which of the following? Doesn't CentOS fall under Red Hat? Or does that fall under SUSE? Wait a minute, I think I got that one right. Red Hat distribution families includes which of the following? It includes CentOS. Both of these answers would be correct. Oh, maybe I could have selected more than one answer. Oh, I didn't read it correctly. It says select all the answers that apply. So I should have selected CentOS and Fedora. All right. They tricked me. Or I wasn't paying attention. More like I wasn't paying attention. I didn't read the whole question. Debian. Oh, Debian. 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 All right, I'm going to get that right. All right, I think this is chapter 3 we're getting into. Okay, you have completed chapter 2. Let's summarize the key concepts covered. The Linux Foundation is the umbrella organization for many critical open source projects that power corporations, spanning all industry sectors. It works today Its work today extends far beyond Linux, fostering innovations at every layer of the software stack. The Linux Foundation training is for the community and by the community. Linux training is distribution flexible, technically advanced, and created with the leaders of the Linux development community. There are 3 major distribution families: Linux, Red Hat, SUSE, and Debian. Within Linux, Red Hat, SUSE, and Debian. In this course, we will work with representative members of all 3 families. All right, congratulations, you've completed the Linux Foundation. Next up, Linux philosophy and concepts. Chapter overview.
Ever wonder where Linux came from? In this lesson, we'll discuss the history of Linux, the philosophy, the community, and the components of a Linux distribution. Let's get started.
Alrighty.
Hi, my name is Greg Crow-Hartman. I work at the Linux Foundation as a fellow. I'm a Linux kernel developer. I release stable Linux kernels as well as doing other driver development. Linus releases development kernels about once every 3 months. I do the stable kernels about once every week. I got involved with Linux many years ago. I used to use it where I worked. I was a programmer. I wrote embedded devices, firmware for embedded devices. I had to interact my devices with all sorts of operating systems. Linux was just coming around. It was just getting USB support. I was creating a USB device. I had to get it to work. I contributed a patch to make a change, and it was accepted. I was like, hey, that's great. Over time, I submitted more and more patches, and I wrote a driver for a device I had that Linux didn't support because I was using Linux on my own desktop. Suddenly, over time, I realized that more people were using my driver I wrote for free than anything I'd ever got paid for, because the companies I worked for never did very well. And the dot-com boom started, and there was more and more need for Linux developers. I got a job being a Linux kernel developer full-time and haven't looked back since. It's been a great, great opportunity, and I've really enjoyed doing this. Linux is an operating system. At its core, it's just a kernel. It talks to the hardware, it makes the hardware work, it makes it able to run programs that do what you want to do. It's very unique in the fact that there are lots of other operating systems out there, but our development community is very different. We have over 2,000 developers every year contributing to it from over 400, maybe 500 companies. It's the largest single software project ever in the history of mankind. We contribute at a rate of about, 10 patches a day, 24 hours a day, 7 days a week go into this code. It's constantly updated, constantly revised, constantly changing because the world changes and we have to react to a changing world. If an operating system stops changing, and the world, of course, doesn't stop changing, it will die. Linux constantly is improved, constantly is updated in order to handle the changing world. The more you know about Linux, the better off you can be. Linux is used everywhere and we need help using it. There's almost no part of the world that does not use Linux. If you have skills in Linux, we have tons of jobs out there. We need people who are programmers, we need people who are sysadmins, we need people to document the stuff, we need people to test the stuff. And it's a fun thing to play with. You can play with it and create things out of it, so you can also have fun while you're doing it, and you help feel that you're part of a larger community that's doing something great. This course will teach you the fundamentals of what Linux is, how to use the command line, how to use the graphical interface. It is self-guided. You can sign up for it at any time and take it at your own pace. Thank you for your interest in Linux. I hope you enjoy the course. Linux is a wonderful experience. It provides great opportunities for jobs, for future, for creating new and wonderful devices. I hope you enjoy this.
All right. 3 important pieces of context. Keep these in mind. Things change in Linux. No matter how hard we have to work at staying current, Linux is consistently evolving, both in the technical level, including kernel features, and at the distribution and interface level. So please keep in mind, while we have tried to keep as up to date as possible at the time of this course was released, there are likely to be changes and new features we have not discussed. This is unavoidable. We have repeated some things in this class material. It is just about impossible in the course this comprehensive to never revisit topics that have previously been covered. And short reviews are helpful, so you do not have to go scouring through earlier sections to jog your memory. This is particularly true with the system configuration items, like how to use sudo to gain temporary root privileges in as safe a manner as possible. We know we have done this, and at least in most cases, it is by design, not by accident. We did not do this. If we did not do this, it would take a long time before we would know enough to perform useful tasks and work on lab exercises. We have tried to oh my gosh, we have tried to avoid holy wars. There are many areas where these are strong preferences, disagreements in Linux and wider open source community. Examples include the best editor, Emacs versus VI, the best graphical desktop, GNOME versus KDE, etc. Often we have chosen a particular alternative to emphasize just to keep things clean. For example, we talk much more about GNOME than KDE simply because has a bigger use base and many more students will be using it, not because we are taking a position as to which is superior. Right on. Final thoughts. In order for you to get the most out of this course, we recommend that you have Linux installed on a machine that you can use throughout the course. You do not need to view the course material on a Linux machine. All you need is the browser. However, you will need to see that there are a lot of follow-along activities and labs that you will benefit from only if you can do them on your own machine. We have prepared a brief installation guide preparing your computer for Linux training, see below, that helps you select a Linux distribution to install, decide on whether you want to add a standalone pure Linux machine or do dual boot one, whether to do a physical or virtual install, and then guide you through the steps. We will also discuss the installation procedure in detail in later sections. We will not cover everything in comprehensive detail. Keep in mind, most of the documentation in Linux is actually already on your system in the form of man pages, which we will discuss in great detail later. Whenever you do not understand something or want to know more about a command, program, topic, or utility, just type man and then the topic in the command line. We will assume you are thinking this way and not consistently repeat. For more information, look at the man page for a topic. Is that a thing? Let me see something here. For purposes of this, let me bring up the command line. I'm just kind of curious. Let me see. Let me just bigger. Oh, they're just saying a topic. Let's type in man. Oh, there. Okay, that's working. On a related note, throughout the course, we will use shorthand that is common in the open source community when referring to cases where the user has to make a choice of what to enter. For example, name of a program or file. We use shorthand like insert file name here. So be aware, we are not actually suggesting that you type these words exactly like I had just done when I top man topic. Good dummy. But be aware, we are not actually suggesting you type these exact words, but that you substitute the appropriate file name for any other string. I just did that. Okay, preparing your computer for Linux training. In this class, we intend to be very hands-on. In order to learn about Linux, you must use it. In order to try out the various steps described in this class and to perform the exercises, you will need Linux installed on your computer. If you already have it running, you don't really need to read the rest of this document. Okay. Well, we already have it running, but I'm just going to skim through it just for the heck of it to see if there's anything. Desktop Manager, GNOME or KDE, which controls the look and feel. Software section. You can use man, like a manual on how to use manual. Oh my gosh, you're right. I didn't know that. man-k. Man is the systems manual pager. Each page argument given to man is normally the name of the program, utility, or function. The manual page associated with each of these arguments is this then found and displayed. It's man. What's man 7? I don't know what that is. Oh, wait a minute. This might be something that would be good for me. Man-A intro. As a beginner, that might be something I should check out later. Let's see here. Some of these are way far beyond what I can do. There's a man F S-mail. Look up the manual pages referenced by S-mail and print out for short descriptions of any found. Equivalent is what is S-mail. Okay, let me get back into here really quick. So this is just going over the installation guide for installing Linux for the purposes of this course. So let's see. I'm kind of curious what they say that they're suggesting. Now, keep in mind that this course was probably written at least 4 or 5 years ago. Let's see what they're suggesting. I think they're suggesting CentOS, Ubuntu, and OpenSUSE. And then they give the links to all of them here. Okay, then they give links to actually how to install them if you need help with Debian, OpenSUSE, CentOS, Stream, Fedora, and Ubuntu. I have trouble with saying that word for some reason. I don't even know if I'm saying it right. Ubuntu. How to pronounce Ubuntu? Ubuntu.
Ubuntu. Ubuntu. Ubuntu. Ubuntu. Ubuntu. Ubuntu.
The best way to learn Linux is by doing it. And this is very much a hands-on class. And so you'll need to have a Linux system up and running. That can either be a native Linux system on your hardware, one running through a live USB stick or CD, or a virtual machine running through a hypervisor. We'll show you all these methods, so let's get going.
All right. Here we go. By the end of this chapter, you should be able to discuss the history and philosophy of Linux, describe the Linux community, define the common terms associated with Linux, discuss the components of a Linux distribution. Oh man, they're going over this again. I thought we went over this in the first chapter. Linux is an open source computer operating system. I'm going to go through this fast because we went over this in chapter 1. It has been subsequently ported to an astounding long list of other hardware platforms, from teeny embedded appliances to the world's largest supercomputers. In this section, we will follow the surprising history of how Linux evolved from a project of one Finnish college student, Linus Torvalds, into a massive effort with an enormous impact on today's world. And there's a picture of Linus. Linus Torvalds was a student in Helsinki, Finland in 1991 when he started a project, writing his own operating system kernel. He also collected together and/or developed the essential ingredients required to construct an entire operating system with his kernel at the center. It wasn't long before this became known as Linux kernel. In 1992, Linux was relicensed under the General Public License GPL by GNU, a project of Free Software Foundation, or FSF, which promotes freely available software, which enables it to build a worldwide community by developers. By combining the kernel with other system components from the GNU project, numerous other developers created complete systems called Linux distributions, which first appeared in the mid-90s. Welcome to the world of Linux. Let me mute my mic while this plays.
Nobody can control Linux. I don't have any more rights than you have.
For co-inventing the Unix operating system and the C programming language, which together have led to enormous advances and have stimulated the growth of an entire industry, thereby enhancing American leadership in the information age.
It's not enough just to be stable, and it's not enough just to be fast, and it's not enough just to be virus-free. You've got to be punchy and clear and beautiful.
Linux is 20 years old. The web is less than 7,000 days old. Together, they have changed human civilization more rapidly than any pair of inventions in the history of the world.
Hey, hold on. I'm going to pause the video for a second. Was that just Richard Stallman with short hair? I've never seen a picture of Richard Stallman with short hair, and his beard was actually maintained. Usually when you see pictures of Richard, his hair is just everywhere and his beard is just everywhere. Let me rewind that. It doesn't say, no, maybe that's not Richard Stallman. I think it is, though, because it really sounds like him. You tell me if you think it's Richard.
1,000 days old. Together, they have changed human civilization more rapidly than any pair of inventions in the history of the world.
We made it possible to use a computer in freedom.
Okay. I think that was Richard. I don't know. I've just never seen Richard with short hair or shorter hair and a trim beard. Anyhow, God bless him. More about Linux history. The Linux distributions created in the mid-90s provide the basis for the fully free and the sense of freedom, not zero-cost computing, and became the driving force in the open source software movement. In 1998, major companies like IBM and Oracle announced their support for the Linux platform and began major development efforts as well. Today, Linux powers more than half of the servers on the internet, the majority of smartphones via the Android system, which is built on top of Linux, more than 90% of the public cloud workload, and all of the world's most powerful computers. Mid-90s, created fully free. By 98, most companies like IBM and Oracle announced support. Today, Linux is used to power over 96% of the world's top web servers and majority of smartphones via Android. So you mean to tell me this phone is being run by Linux? This is an Android phone. Screen's a little dirty, but I had no idea. I thought Android was just Android. I didn't know Android was Linux. Crazy. All right, well, I'm going to have to learn more about that. I wonder if you can run like terminal on your phone. That would be crazy. All right, next page. Linux philosophy overview. Every successful project or organization needs an implicit or explicit philosophy that frames its objectives and projects in its growth path. This section contains a description of philosophies adapted by the Linux community and how it has impacted Linux amazing evolution. Yeah, I've never seen him with short hair either. Linux, but it sounded just like him in that video. That was definitely his voice. It sounded exactly like how he sounds today. Linux is constantly enhancing and maintained by a network of developers from all over the world, collaborating over the internet with Linus Torvalds at the head. Technical skills, a desire to contribute, and the ability to collaborate with others are the only qualifications for participation. So if you guys wanted to participate and offer your services, apparently you can. Awesome. The Linux philosophy. Linux borrows heavily from the well-established family of Unix operating systems. It was written to be a free and open source alternative. At the time, Unix was designed for computers much more powerful than PCs, and furthermore, it was quite expensive. Files are stored in a hierarchy file system with the top node of the system being root, or simply slash. Whenever possible, Linux makes its components available via files or objects like that. Wait a minute. Linux makes its components available via files or objects that look like files. Processes, devices, and network sockets are all represented by file-like objects and can often be worked with using the same utilities used for regular files. Linux is a fully multitasking, for example, multiple threads of execution are performed simultaneously. Multi-user operating systems with built-in network and service processes known as, is it daemons or demons? It's not demons, is it? Daemons? In the Unix world. I'm not sure how to pronounce that correctly. Daemons or demons? I don't think they would call it demons, would they? Is it daemons? Sorry, I'm still running some updates on that laptop. Okay. Note, Linux was inspired by Unix, but it is not Unix. I guess that's what GNU stands for, right? GNU, not Unix. I guess that's the same thing. Siri, Android 16 and up will have it natively built in. My phone is just older than that. Android 16, my phone's a little bit newer. Here, let's Google it really quick. Oh, wow, get out of here. Yes, recent version, just like Siri just said, it says, recent versions of Android 15 and later have a built-in Linux terminal that can be enabled in the developer options. This feature runs a virtualized Debian environment, allowing users to run Linux command and install app, just like in Mint that I'm running. No way. This is a native Android feature and not a third-party app. All the third-party terminal apps are also available on the Play Store. How to enable the built-in terminal. Enable developer options. Go to Settings, About Phone, and tap Build Number 7 times. Access Linux development environment. Go to Settings, System, Developer Options, and find the Linux Development Environment option. Enable the terminal. Toggle the feature on. You may need to wait for the virtualized environment to install. Launch the terminal. The new terminal app will be installed on your app drawer, ready to use. What you can do: run a full Linux command line with access to many common Linux commands. Use package managers like apt to update the Linux system and install new software. Perform development tasks such as running a web development. So get out of here. All from your phone? That's incredible. Wait a minute. Hold on. Here's a website. Who wrote this? DeepAKNest. This is deepaknest.com/blog/Android Linux terminal. I heard about this news of Google preparing to let you run Linux apps on Android back in October of 2024. And then a few days ago, I learned that it's actually live on Android 15, so I had to try it out. To enable this, I had to go into the developer options and settings to enable Linux development environment options. It downloads 500 megabytes of data before the terminal actually starts. Get out of here. This is crazy. So here's the first screenshot, install Linux terminal. And then it shows like all your processes and stuff like that. And then bam, there it is. There's his terminal. It's Droid at localhost. Yes, I installed NeoFletch and HTOP, and you can see how it looks above. And then I suddenly got the idea to install Node.js and run basic Next.js app. And it just took me about 5 minutes to install everything, and the app was up and running. I even recorded the screen with a bit of commentary, so you can watch here. I can't play this video because I haven't given, what's it called? I haven't given credit to this person in the video description, I don't think. I'll do that later tonight. Let me type up a little thing for that, and I'll put that in the video description. So I don't want to play his YouTube video without giving him credit for it. At the very first, I installed the Node.js and npm by running below command. So he just put it. I mean, it's simple. It's the same thing that we've been doing here in my terminal. Sudo app install Node.js, sudo app install npm. Let's see if he has any other screenshots. Can I install a GUI on it? No, sadly, you cannot install an environment, desktop environment on it, as Google has already made clear. Actually, I tried running sudo task sel command, but nothing happens. Can I install GUI apps on it? No, you cannot run GUI apps either. For example, I installed VS Code Editor, but it doesn't open, even if you run code command inside a folder. What are the benefits of native terminal over Termux or Termux? The only benefit that I see is that you can install packages directly from sudo app install package name command. You have access to 10,000 or more apps, but only terminal apps tools will actually run on it. And if you want to learn more about this, I found a detailed post discussing this that you can refer to. How's the opening speed? It's slow. Takes somewhere from 10 seconds to 20 seconds on my Pixel 7a device. Unlike Termux, it runs using KVM, and that's the reason it's slow. Can the terminal access Android files? It can access Android's files, device downloader folder, but cannot access the folders or files. To access the download folder, you need to run the following code: cd/mount/shared. I have created another video where I'm using the Linux terminal and showing what it can do and what it cannot. This is a quick video, so if you want to watch this, you can just go to deepaknes.com/blog/android-linux-terminal. Let me see if I can copy that and put it in there. I'll put that in chat really quick, so if you want to go right to it. There's the link to this gentleman's website if you want to check it out. Here's an update he wrote back in April. I received the email from a person asking about an issue that wasn't able to install any tools. For example, the person was trying to install NeoFetch and it was constantly showing errors, as you can see explained in this screenshot. Update. I received another email where a person got the internet working by using cellular data. Below is how you can use it to terminal the internet, blah, blah, blah. Okay. Anyhow, that's interesting. That's kind of like off topic, but that's pretty darn cool. And you can bet that I'm going to be doing that. I'll figure out some way to get my phone screen up on the computer into OBS, and we will mess around with that because I'm kind of curious to see how it works. So older versions can still install Termux. I haven't tried that either. I don't know anything about that. I'll have to play around with that. All right, let me get back on task here because I'm kind of out there. What else did I put in? Where did I leave off? Files are stored in a hierarchy file system with the top. Okay, I think I covered that. Yeah. Let's go to the next page. Linux community overview. Suppose that as part of your job, you need to configure a Linux file server and you run into some difficulties. If you are not able to figure out the answer yourself or get help from a coworker, the Linux community might just save the day. There are many ways to engage the Linux community, even if you are not a developer. Post queries on relevant discussion forums, subscribe to discussion threads, join a local Linux groups that meet in your area. I really wish we had something like that here. I live in a very small community out in the middle of nowhere, so I know there's nothing like that where I live. I think the nearest town to me where there's actual population is probably about 45 minutes, and maybe they might, so I'll have to search that. Maybe they have a Facebook group or something like that I can join. I mean, shoot, we're building a little community here ourselves. Maybe in a couple months, we'll have enough people on Discord where we can set up maybe a chat room on there or something like that, where you can submit questions. Like a little, I'll work on that. When I get the new Discord up, I'll create a chat room in there where people can it'll be like called like, I need help or questions or something like that. And hopefully we can get a lot of people to join it. Because the more people that we have, the more questions we can get answered. I'm going to mute my mic. I'm going to play this short little video really quick.
It was August of 1991, and a 20-year-old computer science student named Linus Torvalds sat down at his computer in Helsinki to post what is now one of the most famous entries in computing history. Hello, everybody out there. I'm doing a free operating system, just a hobby, won't be anything big and professional like GNU. It probably will never support anything other than AT hard disks, as that's all I have. Well, word of Linux open source project quickly spread around the globe, and developers from all over contributed their code. Linus named his OS kernel Linux and chose a penguin as its mascot, after a little incident at the zoo. He soon made a very important decision that would shape Linux's future just as much as the technology. He chose the GPL license created by a visionary named Richard Stallman. The Linux kernel, along with the GPL license and other GNU components, revolutionized the computing industry with a few very simple yet very important freedoms. The freedom to use the software for any purpose. The freedom to change the software to suit your needs. The freedom to share the software with your friends and neighbors. And the freedom to share the changes you make. These radical ideas fueled its spread around the world, and somewhat paradoxically, its rise from a hobbyist experiment to the foundation of a large and thriving commercial ecosystem. Companies built businesses around Linux. In 1999, Red Hat's stock tripled as it became the first Linux company to go public. That same year, IBM spent $1 billion to improve and advertise Linux.
Does he have a name? His name is Linux.
Soon, Linux was knocking out industry heavyweights and fueling the rise of the internet with its free software. In short, Linux revolutionized computing. But whenever something is this disruptive, there's bound to be competitive crossfire. But Linux not only survived, it thrived. Today, the kernel development community numbers in the thousands, with hundreds of companies collaborating on Linux development. Every 3 months, another version of Linux is released. So, where is Linux today? Running in 75% of stock exchanges worldwide, and powering the servers that deliver Amazon, Facebook, Twitter, eBay, and Google. You use Linux literally every time you surf the internet. It's in your phone, in your TV, running 95% of supercomputers, and in many of the devices you use every day. Linux is everywhere. And the Helsinki-based programmer who started it all? He orchestrates this worldwide army of developers from his home office in Portland, Oregon, as a fellow at the Linux Foundation.
All right, so apparently Linus lives in Portland, Oregon now, or did at the time of that video was made. I didn't know that. I used to live out in Portland. More about the Linux community. The Linux community is a far-reaching ecosystem consisting of developers, system administrators, users, and vendors who use many different forms to connect with one another. Among the most popular are Internet Relay Chat, IRC software such as WeChat, HexChat, Pigeon, and XChat. Online communities and discussion boards includes Linux user groups, both local and online. Many collaborative projects hosted on services such as GitHub and GitLab. News groups and mailing lists, including the Linux kernel mailing list, community events, hackathons, install fests, open source summits, embedded Linux conferences, and many other conferences and get-togethers. A portal to one of the most powerful online user communities can be found at linux.com. This site is hosted by the Linux Foundation and serves over 1 million unique visitors every month. It has active sections on news, community discussion threads, free tutorials, and user tips. We will refer several times in this course to relevant articles or tutorials on the site. There are also many e-learning courses on Linux and other related technologies, such as this course on edX. Many are no or low cost, and there are many more expensive training opportunities with live instructors, either in person or over the internet. The Linux Foundation training website offers many such courses in all these categories, but is by no means the only place you can look. I want to pull that up really quick and see if they put a list of, well, I guess I could just bookmark those other ones. Looking to improve your open source skills or networking other technology professionals. Okay. I'll come back to that. Well, there's a lot of cool stuff on there to read. I'm going to be reading a lot tonight. I can tell. I've been reading nonstop since Thursday, just reading and reading and reading. A lot of man pages, believe it or not. It's probably really nerdy, but I'm determined to learn this. What OSS products do you use? Click on the two boxes in Lab. List some of the open source products you probably use day to day, solutions. Below are some examples in the majority of smartphones and other mobile devices worldwide built on top of the Linux kernel. Apache Web Server, HTTPD. About half of all the web servers are running Apache and its related products. Social media. Virtually all social media platforms, Facebook, Twitter, Instagram, etc., use OSS components throughout. Search engines. Google and other search engines have vast data farms running Linux. Weather forecasting. I know that for a fact because I use a lot of weather forecasting programs for this channel, and a lot of the websites that I have to access, I know for a fact that a lot of their big computers, like the ones that are doing the weather forecasting, are running Linux for sure. So essentially 100% of the world's supercomputers run Linux, and forecasting the weather is one of the most intensive uses. And like I said, I can attest to that because some of the computers that they use for forecasting are incredible. I guess they're considered supercomputers, and some of the stuff that they can do, it's just mind-blowing. And forecasting the weather, it can be a very complicated thing to do. And even some of the computers that they have running them now are not powerful enough to do what they need them to do. So I would say within the next 5 to 10 years, hopefully shorter, we'll have computers that are a lot better at forecasting the weather. Actually, President Trump, I think it was back in March or April of this year, he cut off a lot of funding to the National Weather Service and moved that money into developing new computers and software to better predict the weather. So a lot of people were complaining, oh, why did he remove some of the money from, I think it was the National Weather Service. It was in fact to develop these new computers. So we would have much better weather forecasting. And a lot of that had to do with the flooding that took place in North Carolina during one of the hurricanes last year. A lot of those people in North Carolina are still recovering from that hurricane. It's a really bad situation out there. So that was one of the things that really prompted the government to move some of those funds into a different direction so we could have better weather forecasting. So if you're into weather and that kind of thing, which you should be, if you live in an area where they have a lot of natural disasters, weather related, that's going to be very important. So hopefully keep our fingers crossed that they make leaps and bounds improvement on those systems and new systems. Personal devices, including Fitbit, DVRs, almost all set-top boxes and video recorders run Linux. Medical devices, a large number of medical devices used routinely every day are running embedded Linux. All these projects make extensive use of OSS tooling such as GCC, Make, glibc, and languages such as Python, Perl, and Ruby. Very interesting stuff. Okay, Linux terminology overview. This is probably going to be really good for me. When you start exploring Linux, you will soon come across some terms which may be unfamiliar, such as distribution, bootloader, desktop environment, etc. Before we proceed further, let's stop and take a look at some basic terminology used in Linux to help you get up to speed. And I'm going to mute my mic again for this video.
Before you begin using Linux, you need to be aware of some basic terms, such as kernel, distribution, bootloader, service, file system, X-Window system, desktop environment, and command line. These are very commonly used by the Linux community. The kernel is considered the brain of the Linux operating system. It controls the hardware and makes the hardware interact with the applications. An example of a kernel is the Linux kernel. The most recent Linux kernel, along with past Linux kernels, can be found at the kernel.org website. A distribution, also known as distros, is a collection of programs combined with the Linux kernel to make up a Linux-based operating system. Some common examples of a distribution are Red Hat Enterprise Linux, Fedora, Ubuntu, and Gentoo. The bootloader, as the name implies, is a program that boots the operating system. Two examples of a bootloader are Grub and ISO-Linux. A service is a program that runs as a background process. Some examples of the service are HTTPD, NFSD, NTPD, FTPD, and NAMED. A file system is a method for storing and organizing files in Linux. Some examples of file systems are ext3, ext4, FAT, XFS, and ButterFS. The X-Window system provides the standard toolkit and protocol to build graphical user interfaces on nearly all Linux systems. The desktop environment is a graphical user interface on top of the operating system. GNOME, KDE, XFCE, and Fluxbox are some examples of the desktop environment. The command line is an interface for typing commands on top of the operating system. The shell is the command line interpreter that interprets the command line input and instructs the operating system to perform any necessary tasks and commands. For example, bash, tcshell, and zshell.
All right, sorry about that. My voice is getting a little rough. I needed to get something to drink here. Linux distribution overviews. If you are building a product designed to run on Linux, project requirements will surely include making sure the project works properly on the most widely used Linux distributions. To accomplish this, you need to learn about the different components, services, and configurations associated with each distribution. We're about to look at how you would go about doing exactly that. Linux distributions. So what is a Linux distribution and how does it relate to Linux kernel? The Linux kernel is the core of the operating system. A full Linux distribution consists of kernel plus a number of other software tools for file-related operations, user management, and software package management. Each of these tools provide a part of the complete system. Each tool is often its own separate project, with its own developers working to perfect that piece of the system. While the most recent Linux kernel and earlier versions can always be found in the Linux kernel archives, Linux distributions may be based on different kernel versions. For example, very popular RHEL, the Red Hat Enterprise Linux 8 distribution, is based on the 4.18 kernel, which is not new, but is extremely stable. While the newer RHEL9 distribution is based on the much later 5.14 kernel. Keep in mind that this is several years old, so these might be kind of old. Other distributions may move more quickly in adopting the latest kernel releases. It is important to note that the kernel is not an all or nothing proposition. For example, Red Hat Enterprise Linux CentOS has incorporated many of the more recent kernel improvements into their customized older versions, as has Ubuntu, OpenSUSE, Fedora, etc. Examples of other essential tools and ingredients provided by distributions including the C, C++, and Clang, I guess that's how it's pronounced, Clang compilers. The GBD debugger, the core system library applications need to link with in order to run. The low-level interface for drawing graphics on the screen, as well as the higher-level desktop environment, and the system for installing and updating the various components, including the kernel itself. All distributions come with a rather complete suite of applications already installed. Let's see what this is. So you have the Linux kernel at the center, support services, commercial community, package updates, upgrades, kernel, and driver packages, applications, library utilities configurations, documentation for commands, applications, and services. All right, on. The vast variety of Linux distributions are designed to cater to many different audiences and organizations according to their specific needs and tastes. However, large organizations such as companies and government institutions and other entities tend to choose the major commercially supported distributions from Red Hat, SUSE, and Canonical, Ubuntu, CentOS, CentOS Stream are popular free as in no-cost alternatives to Red Hat Enterprise Linux, and are often used by organizations that are comfortable operating without paid technical support. Now that new versions of CentOS disappeared at the end of 2021 in favor of CentOS Stream. However, at least two new Red Hat Linux, Enterprise Linux derived substitutes, Alma Linux and Rocky Linux, okay, those are new to me, have established a healthy foothold. I guess that must be like the enterprise stuff. RHEL variants such as CentOS and Alma Linux are designed to be binary compatible with Red Hat. In most cases, binary software packages will install properly across the distributions. Ubuntu and Fedora are widely used by developers and are also popular in the educational realm. Many commercial distributions, including Red Hat, Ubuntu, SUSE, and Oracle, provide long-term fee-based support for their distributions, as well as hardware and software certifications. All major distributors provide updated services for keeping your system prime with the latest security and bug fixes. and performance enhancements, as well as to provide online support resources. So at the center, Linux support and services, and then you have commercial support and services, community support and services. So I wonder if there's companies out there that are independent that just offer support for. There must be, unless you're a big company like maybe Amazon or Google or Facebook. They probably have in-house folks that they hire to manage their systems. Or I wonder if they outsource that. I'm going to look into that and figure that out. I'm sure there must be a lot of companies out there that you can outsource to that will manage your system. Congratulations on completing chapter 3. When did Linus Torvalds start writing Linux kernel? I think that was 1991. Correct. Which of the following statements associated with the Linux philosophy are true? Select all that apply. Linux is free and an open source operating system drawing on the Linux legacy. I thought it was the Unix Linux, maybe? I don't know. Processes, devices, and network sockets are all represented by file-like objects and can all often be worked using the same utilities used for regular files. I'm not sure about that. Linux makes its components available via its servers. I think so. I don't know. In Linux, all files are stored in one united directory tree starting at L, the system root. In Linux, all files are stored in one united directory, which is root. I think that's right. I'm not sure. I'm going to just select these. I don't know. Let's go. Which of the following qualifications are required for participating in Linux kernel development? Technical skills and desire to contribute. You don't need to be a citizen. University degree, a desire to contribute, and technical skills. Which of the following communication channels does Linux community use to communicate? CNN.com, IRC channels, mailing lists, community events. It's not CNN. Maybe IRC, mailing lists, and community events. Let's try that. What is a kernel? A glue between hardware and applications, a collection of software making up Linux-based operating system, a program that runs a background process, a graphical subsystem on nearly all Linux systems. I think it's a collection. Oh gosh, it's either A or B, I would guess. It's not a program. I don't know. It's either A or B. I don't know which one. I'm going to go with that. Incorrect. What was the correct answer? Was it A? What is the desktop environment? A collection of software making up Linux-based operating systems, a program that runs as a background process, a graphical subsystem on nearly all Linux systems, a graphical user interface on top of the operating system. I think it's D. Correcto mundo. What is a command line? A collection of software making up a Linux-based operating system, a program that runs in the background process, a interface for typing commands for the operating system to execute, a list of commands requested to be run in, I think it's C. I think it's that one. Correctamundo. In addition to the kernel, what are some of the purposes of the other software tools required for developing a Linux distribution? Select all that apply. Performing file-related operations, catering to different audiences, maintaining user management. I know that's probably one. Taking care of software package management. I think that's right. I don't know. Probably not. Which of the following are binary compatible Linux distributions, which are free alternatives to Red Hat Linux Enterprise? I think it was Cent. I think it was just Cent. I think that's the downstream of Red Hat. Which of the following are binary compatible Linux distributions, which are free alternatives to, alternatives. OpenSUSE and OpenSUSE, I guess. I thought it was CentOS. Let's see. Incorrect. Okay, it was OpenOS. All right. You have completed chapter 3. Let's summarize the key concepts covered. Linux borrows heavily from the Unix operating system, with which its creators were well versed. Linux accesses many features and services through file and file-like objects. Linux is a fully multitasking, multi-user operating system with built-in networking and service processes known as daemons. Linux is developed by a loose confederation of developers from all over the world, collaborating over the internet, with Linus Torvalds as the head. Technical skills and a desire to contribute are the only qualifications for participating. So that was one of the questions right there. Technical skills and a desire to contribute. The Linux community is a far-reaching ecosystem of developers, vendors, and users that support and advances the Linux operating system. Some of the common terms used in Linux are kernel, distribution, bootloader, service, file systems, X-Window systems, desktop environment, and command line. A full Linux distribution consists of kernel plus a number of other software tools for file-related operation, user management, and software package management. Cool. Linux basics and system startup. I'm gonna mute my mic.
In this session, we will discuss the Linux boot process from the bootloader into the graphical user interface. We will also talk about planning a Linux installation, as we have a lot of choices to make, and we will guide you through the installation of a Linux system. Let's go.
Alrighty, let's proceed. Learning objectives. By the end of this chapter, you should be able to identify Linux file systems, identify the difference between partitions and file systems, describe the boot process, install Linux on a computer. Cool beans. The boot process. The Linux boot process is the procedure for initializing the system. It consists of everything that happens from when the computer power is first switched on until the user interface is fully operational. Having a good understanding of this step in the boot process may help you with troubleshooting problems, as well as with tailoring the computer's performance to your needs. On the other hand, the boot process can be rather technical, and you can start using Linux without knowing all the details. Note, you may want to come back and study this section later if you want to first get a good feel for how to use Linux. So I'm gonna take a picture of that so I can come back to it later. And let's call this boot process. Let's save that to my picture folder. I want to make sure that's saved. Let's see. Yep. Okay. I just want to make sure I saved it to the right folder. Okay. So you power on your computer. It goes into BIOS. It goes into master boot record, or MBR, or EFI partition. So that must be that little partition. I want to show y'all something really quick. I have two questions. The first one, when I look at the disks on my computer, if I go to my hard drive, let me move it over here really quick. So on my hard drive, there's a partition called partition 1. It says 537 MB, which is, I guess, megabyte fat system, I guess. Is that the, my question is that the partition that stores root, or is that the partition that stores like your basic files just to start the computer? Like, it's not BIOS, I guess, but is that root in that one partition? And then in partition 2, that's the larger part of the hard drive where it stores, I guess, all my files, applications, directories, that kind of stuff. I was kind of curious about that. And then the other question that I have that I don't understand is that supposedly this computer, and I don't know how to find out exactly, but from my understanding, when we were putting this computer together, we put 32 gigs of RAM in it, I think. I'm pretty sure. And I think that's what it's showing right here on NeoFetch in memory. Right there. But when I'm in the terminal and there was a command line that I put in there, a command, or maybe it was one of those programs that show you like how much memory you're using. It was only showing like 7 gigs of RAM. I don't know. That's one thing that I couldn't figure out. So the first part, let me go back to it again. So that first part that's in blue, that's my EFI bootloader partition. The step after BIOS. Okay, so that's what they're showing here. So you power on your computer, it goes into BIOS, and then it goes into the EFI bootloader. The root is on partition 2. You're thinking of top or Utah. Okay, yeah, that's exactly what I was thinking of. NeoFetch does not accurately measure memory. Okay. Because I'm quite certain that we put 32, it was like it was a stick or something like that of RAM, and the guy told us that it was 32 gigs. But and I'm pretty sure I saw somewhere, like one of these apps that show you your system, that it was correct. It was 32, but like some program that I ran through terminal didn't give us the accurate number. And one person explained to me is that maybe that the terminal was saying that this is how much is available versus how much RAM was being used in virtual memory or something. I didn't follow him. I didn't really understand what he was talking about. And here's another thing. I don't know what this is. Documents, Baofeng. I think that's a program that I use for my little ham radio that I have. I don't know why that's mounted. I don't know what's the deal with that. So that answers my question. The partition 1 is the EFI bootloader, right? But is that something that Linux wrote in there? Like, is that specific to, like, for example, Linux Mint as the distro that I'm using? It's saying, okay, after BIOS does its thing and mounts all the like USB ports and stuff like that, and tells it what partition to boot from. Partition 1, I guess, is where all the stuff for Linux Mint is. But then everything else on the hard drive, that's where my root would be inside there. So maybe partition 1 is like setting up the computer and that kind of stuff. I'll have to research that a little bit more. Maybe if I just follow this chart that they provided, that would answer my question. Okay, so power on, then it goes into BIOS. And then, as you mentioned, the master boot record, EFI partition. The next thing is bootloader, also known as grub. Then your kernel. And then initial RAM disk. And then it goes into sbin/init, the parent process. Then it goes into command shell. getting the GUI. So your shell is all the stuff on the outside of it, from what I understand. And then graphical user interface, X Windows or Wayland. And I don't know what the difference between the two are. I always hear people in videos say Wayland. I don't know what that is. Let's see. Okay, so Siri says that every OS does that. Windows as well. It's necessary for all computers. Okay. So BIOS does check if the hardware is okay, called the post. Power on self-test. Then the only command it does is look for the boot partition on the disk. That's the EFI. Okay, so power on BIOS. Then BIOS says, okay, this is working or this isn't working. And then it sends it to the boot partition on the disk. So if you have a messed up boot partition, then that will probably mess up the whole boot process of your computer. Wayland is a Windows system protocol similar to X11. Okay. Right on. Awesome. Okay. But I think that's a really important thing for people to understand, especially like me who's new to this kind of stuff, is to understand, because I always wondered, like, when I hit the power on button on my computer, what makes everything come together? You know, what makes it do what it does? You know what I mean? And I think that's a really good thing to fully understand, because if you're going to, like, sort of like how this article was saying, if you're going to troubleshoot something and it stops at a certain process, that maybe you can follow the procedure of the actual turning on of your computer. And if it stops at a certain interval somewhere along that process, you can kind of narrow down to possibly where the issue is happening. So then the bootloader loads the kernel, which initializes the entire system. Okay. Bootloader, kernel, system. Okay. Bootloader, kernel, system. Good deal. Thank you guys. I appreciate that. I haven't had an issue yet when I haven't had an issue with booting the computer. But one day, you know, if that scenario should happen when I'm booting my computer, that there's an issue, I think understanding the process of how the boot process works, how your computer actually turns on, is going to be really important to maybe troubleshooting, because one of the computers, like I said, that I have is like 10 or 12 years old. And I know somewhere down the road, that's the one that I'm planning on using as my media server, just to keep, like, I have a lot of old CDs, like music CDs, and I want to copy them to the hard drive so I can, like, listen to my music on other computers in the house. And I know at some point that older computer is probably going to give me issues. So I think knowing this is really going to be beneficial to me in the future with that computer. One day, hopefully I can upgrade it. But until then, I'm just keeping my fingers crossed that it works properly. But that's one thing that I really need to get into, is troubleshooting why things aren't working correctly. So here's our next step. It gets into the BIOS. It says the first step, while Linux runs on many kinds of hardware, we will concentrate on the x86 family, which is the basis for almost all desktop and laptop PCs. Starting an x86 based Linux system involves a number of steps. When the computer is powered on, the basic input-output system, which is BIOS, initializes the hardware, including the screen and keyboard, and tests the main memory. This process is also called post, power on self-test. The BIOS software is stored on a read-only memory ROM chip on the motherboard. This is the remainder of the boot process. After this, the remainder of the boot process is controlled by the operating system. Okay, so that's when it goes to that other partition, that EFI bootloader, or the EFI that you were describing. Siri said that If the post fails, you get memory test failed or disk missing. If the bootloader fails, you'll land in a grub rescue screen. If the kernel itself fails, it'll happen after grub with a kernel panic. If the system fails after, you know it's the OS itself, at which point the booting fails. It gives you a hint to what you need to fix. That's really good. I'm going to screenshot that. I'm going to screenshot everything you just typed. Let me open this up. And I am going to take a screenshot of that. That's awesome. Bam. Where did it go? Okay, here it is. Let me save that. I'm just going to name this knowledge. Boot knowledge. Let me make sure that's saved to my photos directory or my picture. Awesome. You guys kick ass, man. That's going to help me big time. Because I can't remember all that stuff, but if I save it by taking screenshots, then it'll help me. BIOS to EFI bootloader. Awesome. Thank you. That's awesome. I'm just going to read the last paragraph of that again before I skip to the next page. The BIOS software is stored on a read-only memory ROM chip on the motherboard. After this, so I guess the reason they do that is because if your hard drive or your memory stick or whatever it's called fails, that BIOS will always be on there, no matter what. After this, the remainder of the boot process is controlled by the operating system. All right, I'm going to skip to the next page. Okay, here we go. More into it. Awesome. Master boot record, MBR, EFI partition, and bootloader. Once the post, exactly what you guys were saying in chat, once the post is completed, system control passes from the BIOS to the bootloader. The bootloader is usually stored on one of the system storage devices, such as the hard disk or SSD drive, either in the boot sector for traditional BIOS MBR systems or the EFI partition for more recent unified extendable firmware interface or EFI/UEFI systems. Up to the stage the machine does not access any mass storage media. Then, information on the date, time, and most important peripherals are loaded from the CMOS values after a technology used for battery-powered memory store. Let me read that again. After a technology used for the battery-powered memory store, which allows the system to keep track of the data and time even when the power is off. Oh, they're talking about the little watch battery, I guess, that's on the motherboard. A number of bootloaders exist for Linux. The most common ones are Grub, or Grand Unified Bootloader, ISO Linux for booting from removable media, and Das U-Boot for booting on embedded device appliances. Most Linux bootloaders can present a user interface for choosing alternative options for booting Linux and even other operating systems that might be installed. So that's like for, I guess, dual booting or booting from a USB. When booting Linux, the bootloader is responsible for loading the kernel image and the initial RAM disk for file system, which contains some critical files and device drivers needed to start the system into memory. So BIOS boot, which is the basic input-output system that's stored on the ROM on the motherboard, goes to the master boot record. which goes to the bootloader, to the kernel, to the operating system. The UEFI boot, Unified I thought it was EFI. Oh no, EFI comes after it. Okay, I'm sorry. Start over. UEFI to EFI bootloader to the kernel to the operating system. See, I'm more familiar with the BIOS boot system. I'm not. That must be something newer. Or because I thought that's what we learned in school was the BIOS boot system. That must be something newer, a new process. I'm pretty sure mine is UEFI because remember when we went into BIOS that one night and we were looking to find out why that one computer wouldn't boot? I'm like 99% sure it was UEFI that we saw on the screen. Yeah, I'm almost 100% sure. I'll look at it again, but okay, here we go. Here's the bootloader in action. This is the part that I don't really understand. Okay, for systems using BIOS MBR method, the bootloader resides in the first sector of the hard disk. That's what you guys were showing me on that. So just to look at it. This part right here, that's in blue. So for systems using BIOS MBR method, the bootloader resides in the first sector of the hard disk, also known as the master boot record. The size of the master boot record is just 512 bytes. In this stage, the bootloader examines the partition table and finds a bootable partition. Once it finds a bootable partition, it then searches for the second stage bootloader, for example, grub, and loads it into RAM. For systems using EFI, UEFI, which I think is the one that we're using, UEFI, let me close that, firmware reads its boot manager data to determine which UEFI application it is to be launched and from where. For example, from which disk and partition EFI partition can be found. So like that list that we saw in BIOS, I guess, like, I think mine was like Ubuntu. Another option was CD-ROM / USB, something like that. And then there was like two other things. I can't recall what they were. So UEFI firmware reads its boot manager data to determine which UEFI application it is to be launched and where. The firmware then launches the UEFI application, for example, grub, as defined in the boot entry in the firmware boot manager. This procedure is more complicated but more versatile than older MBR methods. The second stage bootloader resides under /boot. A splash screen is displayed, which allows us to choose which operating system. Okay, so that's when when you hit like F9 or escape or F2, that kind of thing. A splash screen is displayed, which allows us to choose which operating system or kernel to boot. After OS and kernel are selected, the bootloader loads the kernel of the operating system into RAM and passes control to it. Kernels are almost always compressed, so the first job they have is to uncompress themselves. After this, it will check and analyze the system hardware and initialize any hardware device drivers built into the kernel. Yeah, we have UEFI, I'm pretty sure. Y'all saw that, I think, the other night. It was on there. Okay, so here's the next one. The initial RAM disk. The initial RAM FS file system image contains programs and binary files that perform all actions needed to mount the proper root file system, including providing the kernel functionality required for the specific file system that will be used. The loading the device drivers for mass storage controllers by taking advantage of UDEV system, which is responsible for figuring out which devices are present, locating the device drivers they need to operate properly, and loading them. After the root file system has been found, it is checked for errors and mounted. The mount program instructs the operating system that a file system is ready for use and associated with a particular point and overall hierarchy of the file system, the mount point. If this is successful, the INIT RAM FS is cleared from RAM, and the INIT program on the root file system /sbin/INIT is executed. INIT handles the mounting and pivoting over to the final real boot file system. If special hardware drivers are needed before the mass storage can be accessed, they must be in the INT RAM FS image. So here's the diagram right here. The INIT RAM FS goes to programs and binary files, and then that goes to the mount proper root file system, providing kernel functionality, locating devices, locating drivers and loading them, checking for errors in the root file system. That's pretty good. I'm going to take a picture of that one too. I've never heard of this. Let's see what this is. This says text mode login. Near the end of the process, INIT starts a number of text mode login prompts. These enable you to type your user. Oh, okay. That's what it means. Okay. Starts a number of text mode login prompts. These enable you to type in your username followed by your password and to eventually get a command shell. However, if you are running a system with a graphical login interface, you will not see this at first. As you will learn in Chapter 8, command line operations, the terminals which run the command shell, can be accessed using the Alt key plus a function key. Most distributions are 6 text terminals in one graphics terminal starting with F1 or F2. Within the graphical environment, switching to a code console requires pressing Ctrl-Alt plus the appropriate function key with F7 or F1 leading to the GUI. Usually the default command shell is bash, the GUI born again shell, but there are a number of other advanced command shells available. The shell prints a text prompt indicating it is ready to accept commands. After the user types the command and presses enter, the command is executed, and another prompt is displayed after the command is done. So up here, the INIT, username, password, command shell, bash, the GUI born again shell. GNU born again shell. All right. The Linux kernel. This is really kind of what I'm interested in here too. The bootloader loads both the kernel and the initial RAM-based file system into memory, so it can be used directly by the kernel. When the kernel is loaded into RAM, it immediately initializes and configures the computer's memory and also configures all the hardware attached to the system. This includes all processors, input-output subsystems, storage devices, etc. The kernel also loads some necessary user space applications. Hold on, I'm going to read that one part again. When the kernel is loaded in RAM, it immediately initializes and configures the computer's memory and also configures all the hardware attached to the system. This includes all processors, input-output systems, storage devices. So if you have I wonder if that includes like external like thumb drives and like maybe like a hard drive that hooks up via a USB cord or something like that. The kernel also loads some necessary user space applications. Interesting. So then you have the bootloader that goes to kernel, RAM-based file system that goes to memory. The kernel and the RAM-based file system goes to memory. So it's essentially stored in memory then. All right, I do remember part of this from an article that I read. Okay, so that does include USB devices as well. So like if the computer boots and I have a thumb drive or a USB supported hard drive, then that will recognize those. Anything defined in your FS-tab file is mounted as at boot. Okay. So that's what, so then when I'm looking at my GUI and usually on my desktop, I have it set up to where when I plug in or it boots with a USB thing that it will show the drive in there, or when I go to my file thing here, I'll just plug one in. If I can get it to go in there. There it goes. So it found it right there. So had that been plugged in when I was going through the process, then that's the point in the process that it would recognize it and go ahead and mount it, I guess. All right. So there's a lot of things that you kind of need to go over in your mind as the computer is booting. You kind of need to follow the stages in your mind. I mean, if you're just doing something, but I mean, if you're trying to troubleshoot or if you really want to understand it, and that's kind of the point that I want to get to, is that as the computer is booting, I kind of want to go over subconsciously in my mind, okay, what is the computer doing? You know, and I don't mean the CPU, I mean like your whole system. What is the system doing to get this box to do what I want it to do to get me eventually to the user interface? Okay. Once the kernel has set up all its hardware and mounted the root file system, the kernel runs sbin/init. This then becomes the initial process, which then starts other processes to get the system running. Most other processes on the system trace their origin ultimately to init. Exceptions include the so-called kernel processes. These are started by the kernel directly, and their job is to manage internal operation system files. Besides starting the initial init, I'm sorry, let me restart that. Besides starting the system, init is responsible for keeping the system running and for shutting it down cleanly. One of its responsibilities is to act when necessary as a manager for all non-kernel processes. It cleans up after them once completion and restarts user login services as needed when the user log in and out, and does the same for other background system services. Traditionally, this process startup was done using conventions that date back to the 1980s and System V variety of Unix. This serial process, called sysvinit, had the system pass through a sequence of run levels containing collections of scripts that start and stop services. Each run level supported a different mode of running the system. Within each run level, individual services could be set to run or to be shut down if running. However, all distributions have moved away from the sequential method of system initialization, although they usually can emulate many System V utilities for compatibility purposes. Next, we will discuss the new method, of which systemd has become dominant. Let's go to that. Okay. So kernel, INT, and services, startup alternatives. Systemd or VINIT, viewed things as a serial process, divided into a series of sequential stages. Each stage required completion before the next could proceed. Thus, startup did not easily take advantage of the parallel processing that can be done with the multiple processors or cores found on modern systems. Furthermore, starting up and rebooting were seen as relatively rare events. Exactly how long they took was not considered important. This is no longer true, especially with mobile devices and embedded Linux systems. Some modern methods, such as the use of containers, can require almost instantaneous startup times. Thus, systems now require methods with faster and enhanced capabilities. Finally, the older method required rather complicated startup scripts, which were difficult to keep universal across distribution versions, kernel versions, architectures, and types of systems. The two main alternatives developed were Upstart, developed by Ubuntu, the first included in 2006, adopted from Fedora 9 in 2008, and Red Hat Enterprise Linux 6 in its clones. Systemd, adapted from Fedora first in 2011, adopted from Red Hat Enterprise Linux 7 and SUSE, replaced Upstart in Ubuntu 16.04. While the migration to Systemd was rather controversial, it has been adopted by all major distributions. And so we will not discuss the older System 5 method or System V method or Upstart, which has become a dead end. Regardless of how one feels about the controversies or technical methods of Systemd, most universal adoption has made learning how to work on Unix, almost universal adoption has made learning how to work in Linux systems simpler, as there are fewer differences among distributions. We enumerate Systemd features next. So that's taking us into current times. If you start htop and sort by PID processes ID, you'll see PID1 is Systemd, and then it starts sorting processes following PIDs. I think I have that installed here. I don't know if it'll let me sort. Oh, it does. There we go. So PID1 user root command /sbin/int splash. There's Systemd. Yeah, it's Systemd because it's user lib Systemd system. And then PID 465 is also Systemd. The fourth one is Systemd. The fifth one is Systemd. 1, 2, 3, 4. The 5 first PIDs are Systemd. And then the very next one after that is users lib execute accounts D, and then Damien running, and then et cetera, et cetera, et cetera. Then it goes on and on and on. So I guess INIT, does that stand for initial? INIT is always the first process from which all other processes spawn. On Arch, PID1 is literally Systemd, and Mint is doing it differently despite also using Systemd. Well, Arch is a little different, though, how they do a lot of stuff from what I understand, because after I installed Arch through that VM program, I read a lot of documentation. I mean, there's a lot of documentation for Arch, and I had to read a lot of it. Some of it didn't understand, but a lot of the terminology that they use is a little bit different than what we're using in Ubuntu, and then eventually Linux Mint or Mint. a lot of their terminology was different, even the way that they install files, or yeah, I guess the way they install files. init equals initialization. Okay. You say it like init or got it. Okay, init. Okay, that makes sense. Or you can just say initialization. Okay, init. All right. So we don't have to worry about that system V thing anymore, right? Because that's something in the past that none of the kernels are using now, right? That was sort of like back in the Unix days, or maybe the earlier versions of Linux, maybe that system V or system 5 or upstart. I've never heard of the upstart. I've heard of I've seen system V in documentation, but I've never seen upstart. So going forward, we don't have to worry about that. We just need to know system D. All right, let's go to the next page and see if that starts with system D. There we go. Okay, system D. There we go. Okay, systems with system D start up faster than those with earlier init methods. This is largely because it replaces a serialized set of steps with aggressive parallelization techniques which permit multiple services to be initiated simultaneously. Complicated startup shell scripts are replaced with simpler configuration files, which enumerate what has been done before a service is started, how to execute service startups, and what conditions the service should indicate have been accomplished when startup is finished. One thing to note is that sbin init now just points to lib/systemd/systemd, i.e. systemd takes over the init process. So that takes us back to, what was it, htop we ran there to look at the processes, PID1, and so on, where it's sbin init splash. I'm not sure what that splash stands for, but, and then user lib systemd system. I don't know if we're seeing everything on the screen there. Let's move it over a little bit. Hold on. Oh, there we go. There's more. So sbin init splash, and then user lib systemd journal D. I'm gonna have to Google every single one of these. I'm not sure what that journal D is. Time sync D. Everything ends in D. Time sync D. Interesting. This is doable. I can learn this stuff. It's just a matter of learning all the terminology. Linux uses system V ABI, but don't worry about ABI right now. No, I think I can do this. I think this is doable. I read a lot of documentation over the last couple of days. Like I said, I didn't understand all of it, but it's starting to come together now, little bit by little bit. So I'm really getting excited now because as I read some of this stuff, some of it's starting to click a little bit. Okay, let's go into systemd features. Systems with systemd start up faster than those with early init methods. I think I read that part. Yeah. Okay, here we go. One systemd command, system control, is used for most basic tasks. While we have not yet talked about working at the command line, here is a brief listing of its use. Starting, stopping, restarting a service using HTTPD, the Apache web server as an example on a current running system, which would be sudo system control start, stop, restart, HTTPD service. Enabling or disabling a system service from starting up at system boot, which is sudo system control enable disable HTTPD dot service. checking on the status of a service, sudo system control status HTTP service. In most cases, the .service can be omitted. So it's just control. There are many technical differences with older methods that lie beyond the scope of our discussion. I'm going to take a screenshot of that really quick, just so I know. You got to be kidding me. System D is about 1.5 million lines of code. And that's exactly, Siri, why I'm making a website. Because it is a lot of information to remember. And I think by having a website that I made that's in the order where I know exactly how to find things, because I don't want to have to Google every single thing. I want to just be able to go to my website as a reference point. That's why I'm making a separate website from the WeatherZone411 website. I'm still putting Linux stuff on there in the meanwhile, but I'm going to register another domain just for, essentially just for me to go back and refer to things on. But of course it's, you know, available to anybody who wants to use it. You guys probably won't need to use it because you guys are experts, but noobs like me, I think it would be a really good resource to go in and say, okay, if I want to know what system D is, I don't have to search Google every single time. I can go in, and then all the screenshots that I'm taking and little notes that I'm taking, you know, maybe right, if you click on system D or something like that, it'll show you all the different screenshots that I took and stuff. So I think it would be good. It would be a good learning resource. I'm sure there's other really good ones out there, but okay. Lab 4.1, Apache Web Service status. Click on the two boxes to access lab. Lab exercise task. Check the status of HTTPD Apache web server on your system. Okay, let me clear this out. I think it's C. Let's clear this. Let's type in, check the status. If it is running, stop it and check again. Start the service and check the status. You probably want to stop it again. So how do I do that? Okay, here we go. Sudo, whoops, let me type that. Sudo system CTL status HTTPD. I have to put in my password. Okay, it says unit HTTPD dot service could not be found. Did I type that in wrong? System CTL status HTTPD. Let me try start. Failed to start HTTPD service. Unit HTTP service not found. Is that, so are they saying like maybe that's something that I need to install? Journal as a service, systemd provides that logs all kernel and operating system events if something breaks, and you don't know what journal control on terminal will bring up. So would I just sudo HTTPD? Oh no, I'm not running it as a web server, so maybe that's something that I don't need to do. says if you install HTTPD to run a web server which serves web pages and handles requests from browser over the internet, it is a fundamental step for creating a web server. It is as it allows you to host static and dynamic content, manage security with features like SSL, and configure it for various needs like hosting multiple websites. I don't plan on doing that from this computer, so I don't think I want to do that. Try system. Okay. CTL status. System control. System control status NTPD. That didn't show up either. Oh. Oh, I didn't find it with sudo either. It must be something that I don't have installed. Did I type that right? Let's see. Yeah, I just must not have that installed on here. Before we get into Linux file systems, I think this would be an awesome place to take a break. I'm gonna get something to eat. I'm starving. It's it's about 2:15 p.m. here Central Time, and it is 9 p.m. Germany time. Oh, wait a minute. I missed that comment. ITL lists all services you ITLL. Or is it SSHD? Is it sudo? Oh, I missed that. Sorry. I need to scroll up. You need to sudo. I want to try this before I take a break just to see if we can get it to work. Is it space? Yeah, I know I typed that wrong. Hey, what's up, Kat? Oh, no, Kat, it's okay. I was actually putting it in chat because I think the next stream that I do, I think we're going to do it over on the new account on the new YouTube channel. Okay, let's try. List units. It says invalid option U. I don't see a U except for in units. Try. Okay, let me clear this up. Said failed to start, then sudo system status SSD. What do you mean they're not having fun? I love this stuff. Yeah, I don't have anything installed on this one. Well, I have a few things, but not a whole lot. So how about this? I'm gonna take a break, and then when I start I'm gonna pick back up right where I left off here at the Linux file system and try some of these commands that you guys have. But what do you say that when we start back up, let's start on the new YouTube channel that won't get mixed up with the weather stuff. I put a link at the top, I think. Let me see. Maybe I didn't put a link. Let me put a link to it really quick. Here we go. I'm going to put a... Okay, there's the link to the Linux channel. And then when we start live, you won't get a notification on Discord. But if you have notifications turned on the YouTube channel, I think you should get a notification on whatever device that you're doing. But I'll also put on, I really need to get that new Discord set up. I'm going to make that a priority tomorrow to get the new Discord set up and running for Tux distro. So that way we can set up chat forms or forms in there where we can ask questions and people can help each other out in there, and also put screenshots of like stuff and different things on there. I think it would just be a lot easier than separating it from the weather channel, because the weather channel is going to get it's going to get messy with a lot of different stuff in there if people search for stuff. But all right, guys, I'm going to go eat. I'm starving. I'm going to go outside and touch a little bit of grass and breathe some fresh air. And I'll be back in a little bit. All right, guys. Thanks a bunch. I'll see you in a little bit.